8 tons per hour of what? Of steam at 60 bar with 124 degrees Celsius of superheat if the feed water temperature is 31 degree. So the first thing that I'm going to do, I have to figure out data. You have to take note that the steam production SP, it is the same thing as what? As 8 tons per hour. Therefore, this 8 tons per hour, if I should convert it to kg, it will now become what? It will now become 8,000 kg per what? Kg per hour. So you have to take note of it, and therefore I have what? I have my pressure. The pressure, it is what? It is 60 bar. And therefore I have the temperature superheat, which is 124, and I have the feed water temperature, which is 31 degrees Celsius. So I have to use the steam table. To use the steam table at what? At 60 bar. At 60 bar, what shall I going to get? So at 60 bar, let me check. So we have 60 bar here. So I have to say, where is the 60 bar? You can see. Here is the 60 bar, as you can see. Here is 60, 60. Yes, this is 60. This is 60 bar. So after looking for what? For the 60 bar. So you are going straight to what? This is 60 bar. Okay, let me say 60 bar. So you are going straight to temperature. So you can see the temperature, which is 276.6. So our temperature will be 270 what? 275 point what? 0.6. So this will be our what? Our temperature that we are going to use it. So care must be taken. You have to take note of what? Of it. And if you are looking for HG or HF, so you are going straight directly off to what? Off to the what? Off to the last of SG if you are asked to find what? To find the SG or something else. So for now, I hope you see the steam table. If you could recall, at 60 bar we get the temperature of what? Temperature of 275.6 degrees Celsius from what? From the steam table. So the next thing that I'm going to do, so I have to say this temperature will now be equal to the 275.6 degree. I have to say plus what? Plus this temperature. If I say plus the temperature, so it will now be 124. 275.6 plus 124. What shall I going to get? So I'll get 399. I'll get 399.6 degrees Celsius. So the next thing that I'm going to do is that I have to check for what? For the superheated steam table at what? At 60 bar and what? And 399.6. And you have to take note that 399.6, it is the same thing as 400. So now I'm going to check in my steam table. I will check 60 what? I will check 60 bar. After checking 60 bar and what? Checking 60 bar and let's say 400 what? 400 degrees Celsius. So you have to take note of that. So let's check it and see. So what if you are asked for the superheated steam? So as you can see, this is what? This is superheated steam. Superheated steam. So your steam might be different from my own. So at 60 and 400, which is 399.6. So I will first look for 60. So this is 60, this is 60, this is 60. So after then, you are going for what? You are going to look for 400. So this is 400. I'll come across like this, come across, off to what? Off to what? Off to the 60. So if I come across the 60, you can see this is 3177. Yes, this is what I cycle, 3177. So, and it is close to what we are looking for, which is the H under what? The H under our 60 bar. So therefore, the number that I'm going to pick as my H, it is what? It is 3177 kilojoule per kg. So you have to take note of this. So this is the number that we are going to use, but you have to take note, this is superheated steam table. So I hope you see how to find the superheated steam table at 60 bar and and 399.6, which is 400. You have to take note, we find our H as as 31777 kg for kilojoule per kg. And therefore you have to take note that enthalpy of feed water, the enthalpy of feed water, it is always the same thing as Cp multiplied by by T. And the value of the Cp, it is what? The value of Cp as usual, it's 4.187. So it is a constant. So I have to multiply by the temperature. This is the temperature as 31. So therefore this will now be equals to 130 kilojoule per kg. And the heat that is added per kg of of a steam, which is Q, it will be the heat superheated subtract by by the enthalpy of feed water. So this will now be equals to the heat that is superheated, it is it is 3177. So I'll say 3177 subtracted by subtracted by the feed water, by the enthalpy of feed water, which is which is almost 130 or 129.90.8. So I have to say 129.8, because if you multiply this and this, you are going to get 129.8. So I approximately put it as as 130, because it is all the same. So let me see what should I going to get if I say 3177 multiplied by 129.8. Okay, I have to first subtract it. 3117 minus 129.8. So let me subtract this 3177 minus 128 and see what should I going to get. At the end I will end with 3047, and then I have 0.2, which is kilojoule per kg. At the end, I will now say the total heat supply, which is Q, it is the same thing as as MQ. It will now be equal to what will be the value of of M. My mass, which is 8 tons per hour, as I convert it before, it should become 8 it becomes 8,000. So I have to multiply it by by the Q. This is this is a Q that I already find, which is which is 3047.2. So therefore at the end I will get 24,377,600 kilojoule per kg. So therefore at the end, this is the same thing as saying 2.438 approximately, I have to say, times 10 to the power of of 7 kilojoule per kg. So let me convert this in kilowatt. To convert this in kilowatt, I will first say the 24,377,600. This is comma, not a point. It is comma. So I have to divide it by by 3600. If I am to convert it to kilowatts. So let me see what should I going to get. 24,377,600 divided by 3600. So at the end I'll get 6 0.6 kilowatt. So therefore at the end, the final solution of my Q, it is 6.77 megawatt, or I can say the Q is equals to 24.38 times 10 to the power of 6 what kilojoule per kg per what per hour. But I recommended you to put your answer like this. So this is a solution to the first problem. The second question says a boiler plant working at